Hey, welcome to another Flare Court Media tech video. On today's episode, I want to talk about slow motion. Now obviously slow motion is when you run your camera's frame rate faster than what the frame rate is when you export your video and play it back. So if you run your camera at 120 frames per second and you export your video and play it at 30 frames per second, your clip is going to be 4 times as long. And so you get the slow motion effect. But what happens if you record at 30 frames per second and then later on decide you want to try and make that slow motion? Well, if you put in, let's say, Premiere and stretch out the timeline and play it back, it's going to look pretty bad because you're taking those 30 frames and trying to make them last longer, and so it's just really choppy. But in today's episode, I want to talk about an AI that actually will help do a pretty good job take that 30 frames per second and make it into convincing slow motion. I learned this technique from watching Gerald Undone. He's a YouTuber that focuses on cameras and some advanced editing type techniques. So definitely recommend checking out his channel. There's a link in the description below, or it's popping up here. He goes over the slow motion aspect on Windows. Now this AI is designed to run on CUDA cores, which are the processing units on NVIDIA graphics cards. And Gerald on his channel goes over the process of doing that. And so I'm not going to re-explain something that he's already done. I want to tell you how you can do this on a Mac using the CPU, because unless you have an NVIDIA graphics card with an external enclosure using a Thunderbolt cable, you're going to have to use the CPU. Or if you're on a Windows machine and have Intel integrated graphics or an AMD graphics card, you're going to have to use the CPU. Now, if you have access to an NVIDIA graphics card, even a cheaper one like a 970, a 900 series or 10,000 series or something, it's going to be so much faster than using the CPU. Now I found a different use for it besides just taking 30 frames per second footage and making it into slow motion. I found it does an amazing job if you have like a Osmo Pocket or some other kind of gimbal that does a motion time lapse. So that's where you take a picture every 2, 5, 10 seconds, whatever, but the camera moves over the course of 30 minutes to an hour. And so your time lapse scrolls across something. And I found that this AI does an awesome job of taking that and removing some of the stutter. Today I'm going to focus on showing you how to install it on a Mac and run it. If you're interested in Windows using the CUDA process and the slow motion, just go check out Gerald's channel. Okay, so I am on my 2018 MacBook Pro with the 6-core processor and the Radeon 560X graphics card and running macOS Mojave. So let's just go ahead and get started here. So the first thing you're going to want to do is open up your user folder. So mine's Jason Flaherty, and we're just going to make a SloMo folder. When you're doing this, you're going to want to make sure that you use small names for your files. You can just use the ones I use because later on I'll give you a sample command to run, and if you use the same labels as me, then you don't have to change anything, or very little. So we just make a folder, and the SloMo folder is where all of our stuff is going to be put into it. Everything involving this whole project will be in this folder, except for one app that we install. So inside that SloMo folder, we're going to just make another folder, and this one we're going to call Input. And we're going to make another folder called Output. So Input is where the video you want to convert goes. Output is where the video you want, once it's done processing, will go. So then we're going to move in the video that I want to convert, which is this mountain time lapse. So then go ahead and click on the first link in the instructions below, and we're going to install Anaconda, which is a Python distribution. Now, Macs do have Python already built in, but it's an older version. So we're just going to install Anaconda because this whole system is designed to work pretty well with it. Don't let the fact that we're using a programming language or terminal or anything like that scare you, because this is so straightforward. Literally anyone can do it. So just stick with me here. So we will just go ahead and click on download in the Anaconda distribution. And at the time of this video, we're going to download 3.7. Let's just go ahead and install that. It's going to take a while. Their server is pretty slow. This whole process is almost identical between Windows and Mac, but on Windows you use Anaconda's Python terminal, whereas on a Mac we just use the normal terminal that's already on Mac. The only other difference in this process is in a little bit we're going to decide, are we using CUDA cores or are we using the CPU? That's it. Okay, we will just come up here and click continue, and we'll start installing. Continue, agree, install, default location, put in your password. And it's going to take a while because it's a lot of really tiny files, and small files take longer to install than big files. So we'll just skip ahead here. Okay, so we're done. We'll just click continue again and close, and we can just move that to the trash. Okay, now go ahead and click on the next link, which I already have up here in this tab. And this is the actual AI program. It's up on here on GitHub. You don't need an account or anything like that. We're just going to download the code, and just come over here and click on download and just download the zip. No install, nothing like that. We're just going to download the zip and just save the file. That's going to put in our downloads folder. So we open up the SloMo folder that I told you everything goes in, and we'll just drag that new folder we downloaded in and double click it on the Mac to extract it. Now I'm just checking, yep, we want it to be just one level down. We start seeing all these files, so we'll just go back up a level. And we're going to change the name to Super-SlowMo, just for easy typing later. And we can delete the zip file. Now you could make your own AI model, and there's instructions on this GitHub how to do that. And a reason you might want to do that is if the output that this is doing isn't matching the type of slow motion you want. Let's say you have a lot of, tree branches or something, and this maybe doesn't handle it very well because this is just a general slow motion. It's not perfect. Not everything's going to work, but it does a pretty good job in some cases. So you could record a whole bunch of slow motion trees and then train the model, and then it would be able to do trees pretty well. But it's time consuming and you need lots of slow motion footage to train it. So if there's a certain type of slow motion you want to accomplish and this doesn't do it for you, you could train your own. But the programmers here, the PITorch SloMo, have included a model that you can use. If you are interested in making your own, the instructions are here on this GitHub page. But we're just going to use the pre-made model. And so that's another link down there, and that's going to just take us to a Google download superslomo .ckpt. You can go ahead and download that. So we're going to open up our Super-SlowMo folder and come here to downloads and just drag that right into that folder. Don't change the name or anything, just leave it as it is. We'll go back up a level. And now on to the next link in the description below. So this is ffmpeg. It is a video converter. So it's going to be what the AI uses to take our video after processes it and spit it back out. It's designed to use this ffmpeg, so we'll just use it instead of trying to figure out a way to use a different one. So scroll down here and we just want to take the stable version, which is the one that's not the long name. We just want 4.2 in this case, and Mac OS 64-bit, and then static. And we'll just download that build and save it. Okay, same thing. We open up our SloMo folder. We drag this zip file in. We double click it. Delete the zip file. And we will come here and just name it ffmpeg for easy typing. Almost done, really. We're getting pretty close. So now we're going to come over to the PITorch website. Now PITorch is the AI framework basically. So there's all kinds of AI, different versions of AI made using PITorch. The GitHub SloMo that we downloaded earlier is just one AI that was designed to use PITorch. So we need to actually get PITorch so it has something to run. So we're going to go to their website here and scroll down. And here we just need to select what our system is. So in this case, we're using stable. We want the stable again. We're picking Mac. We're picking Conda because we use the Anaconda Python. And we installed 3.7. And because we're not using a NVIDIA GPU, we have to select none, which means that we're using the CPU. So if you were using the Windows with a NVIDIA graphics card, you just here change it to Windows and pick 9.2 is what the SloMo program was designed to use. Don't use 10, use 9.2. And so we're just going to come and copy that. Command C. Now we need to open up just normal terminal. Okay, so we'll just come up here and paste that and hit enter. And that's going to start installing the PITorch all by itself. So it's using the Anaconda Python to do the installation. It's going to take a moment here. Okay, so now that that's done, we just need to get the script that tells the SloMo program how to process our video. So I have that link down below. You're going to have to make a few changes to it. So the best way to do it is to copy the script I have down below and then paste it in like a Notepad or BB Edit, some note editor. And it's just going to be easier to work with in there than trying to do it straight in the terminal. So let me just explain real fast what the different parts of this script are so that you know what to change and how to change it for your video. So Python just means we're using the Python script. Video to slowmo.py, that's the program we're going to run. ffmpeg is what we are using to do the video conversion. So here's just the path to our ffmpeg. So you're going to change that to your name. And if you named it SloMo like me, it's going to be there. And ffmpeg, if you named it like that, you can leave that the same. And just leave it at video. So this next part is where the file location of the original video is. So again, change that to your username. And if you put it in an input folder like mine, you just come here and this is what your file is going to be called. It can handle like a .mov file. It can do the general video formats I've found. So this SF4 here is the multiplier that you're going to slow it down by. So if you're slowing it down from 30 frames to 60 frames, it's going to be 2 because you're slowing it down by half. If you're slowing it from 30 frames to 120 frames, it's going to be 4. If you're doing 240 frames, it's going to be 8. So this next part is where the model is located, and that's the pre-made model that we used. If you're making your own, you'd point to it here as well. So this next part here is the target frames per second. So it's basically just taking your original frames per second. In my case, it was 29.97 frames per second on my original video, multiplying it by whatever your SF is, and that's going to give you your output frames per second. Now I have not tried taking a 29.97 frames per second and outputting it at 120. I don't know if that will cause an issue or not. I didn't feel like trying. So if you're a pure 30, then you could do 120. If you're 29.97 or 25 if you're in England, or 24 if you're doing movies, just multiply that by whatever your SF is. And then this last part is where the output folder is going to be. And so I just named it Mountain 120, so that way I knew this was the slow motion at 120-ish frames per second. So this last setting here, the batch size, is basically how many iterations you're going to run at one time. So changing this on my Mac didn't change anything at all, and that's why I actually submitted the bug report for. But if I running it in CPU mode on my Windows machine changed it to 2, then I forced it to run 2 concurrent iterations of the program, and it used all 32 gigabytes of my memory, that almost all 32 gigabytes, and pushed my Core i7 4-core processor a lot harder. And so it's going to be able to, if your hardware can handle it, do it in twice the amount of time. The same thing works if you're doing it on the NVIDIA GPU, where like if I were doing this 1080p video, I could bump it to 2 and get it done twice as fast because my graphics card could handle it. If your graphics card can't handle it, drop it back down to 1 and see if it can handle that. Now this is where I found out that my GTX 1080 could not do 4K, because even at batch size of 1, I didn't have enough RAM. And you need at least a batch size of 1 because you can't do like a fraction of an iteration. You have to do at least 1 full iteration. So the only thing to remember about this script is just make sure you're in the SloMo/super-SlowMo folder when you run it. Okay, so now we need to change directory into the SloMo folder and Super-SlowMo, which is the one that contains the slow motion project. And now we come to our script. We're going to copy that in. Okay, so we're going to let that start running, and you can just ignore all of these warnings and deprecations. It's going to start processing to see if your computer can handle it. So this is a 10-second clip at 30 frames per second, so we have 300 frames. And right now it's going through its first frame. And so it's going to give us an iteration here in a second of how long each frame is going to take. And I told you, this is CPU, so this is going to be very slow. This 10-second clip I have ended up taking me about 7 or 8 hours on my 6-core processor. So if you're doing this on CPU, which is what we're doing here, I would not even try it on 4K because it's just going to take so long unless you're maybe doing 2 seconds. Even then, that's going to take multiple hours. Your best bet is going to be, if you have 4K footage that you want to do this on, to render it down to 1080p, do your processing, and then upscale it back up to 4K. Even on my Windows machine with the NVIDIA graphics card, I have a 1080 graphics card. There's not enough RAM. 8 gigabytes of GRAM on my NVIDIA graphics card is not enough to process a 4K piece of footage. So I don't have a graphics card that can do 4K, even despite being a pretty decent graphics card. Well, it was a couple of years ago. So just letting you know, so this is going to sit here and process for a little while. Okay, so we got 1 iteration done. It took 86 seconds, 86.49 seconds per iteration. And so based on that, it's going to take about 7 hours and 11 minutes to do this 10-second, 30 frames per second clip. So if you're curious, you can see the frames being processed in real time. Doesn't really tell you much, I guess, just kind of to know it's working. If we come in here to the Super-SlowMo folder and make sure that Show Hidden Files is on, the keyboard shortcut for that is Command-Shift-. And then we see in here the Super-SlowMo, and come in here to Output, and you can see all the frames so far that have been output. So this is each one that's been processed. If we back up and go to Input, you can see that it's broken down our original video into every single frame that's going to process. Just kind of neat. So there's just a little clip. Anyway, I've already processed this video, so I'm going to go ahead and stop this. So let's go ahead and take a look at the actual results here. So let's just open a Premiere timeline, and we will drag in our original and our AI processed files. I think that's pretty neat. So you can get this kind of smooth, slow motion using normal footage, but I found it works amazing for a motion time lapse. Now, not all slow motion processing is going to be accurate. Gerald on his channel, he looks at like 4, I think, different videos, and sometimes it does a better job than others. So you're going to want to try it. Don't rely on it, but give it a try. And like I said, if you really, really want to try and make a certain type of slow-mo, like a dress flapping or trees moving, look realistic, you may just have to end up training your own model, which, now you're looking into a little bit more programming and a lot more time and effort. But for this type of thing, these very steady, predictable, we know what's going to happen type of shots, like a motion time lapse, it does an amazing job. So that's the whole process. I told you it was pretty easy. If you do give it a try and come up with a pretty cool slow-mo video, send me a link on Twitter or on Facebook. FlareCorp Media, I think, is the handle for both of those. Send me a link to your video so that I can see what you were able to come up with this tool. Now, unfortunately, I'm not able to help you generate your own models. I haven't gone through the process myself, and I really don't want to learn it. The instructions are on that website, and so hopefully someone out there can help you if you get stuck with it. But it looks like it's pretty straightforward if you have familiarity with programming a little bit. Well, that's going to do it for this episode. If you appreciated the information you got and want to help other people find it, go ahead and click that thumbs up button. It helps the algorithm share out my video to more people. And if you want to see the slow-mo process on Windows using NVIDIA and on normal footage, not time-lapse footage, then go ahead and check out Gerald and Dunn's channel and video. And if you want to see all the new tech videos and travel vlogs and mountain climbing type videos I do, go ahead and subscribe so that way you get notified when those come out. Or if you don't like the bell notification icon, at least they show up in your feed. But until next time, I'm doing what I love. Keep doing what you love. Thanks for watching.